Hit recording, and we're here. So today's lesson, lesson 2, is inheritance. That's a second principle of object-oriented programming. In the previous lesson, we learned what a class is and what it can do, that its main purpose is to encapsulate and represent real world objects and wrap them in a blueprint called a class, which later on instantiates objects, instances of that class. So today is inheritance. What is inheritance? Inheritance is basically a way to say that one class uses another class in a way that it takes everything from that other class. It inherits all the properties, all the methods, as long as it can inherit it. When can a class inherit the other one? Basically, you inherit everything that is public or protected. So, protected properties, public properties, protected methods, public methods, those get inherited. Now, let's try to design our first inheritance. In previous lesson, we created a baby class. And baby class had months, birthday, name, and we have human stages: adult, child, teenager, toddler. You might think that it would be a good idea to do something like child, let's start with toddler. Toddler inherits baby. Then child inherits toddler. You can click on my name to track where I'm moving. I'm in human stages folder. Then teenager inherits child, and adult inherits teenager. You might think that's a good structure for inheritance because each of those inherits everything that the other one has, but it's not quite that simple. If we go to the baby class, we see that baby's age is actually defined by months, and that is not true anymore for toddler, teenager, child, or adult. So that is not correct already. Another bad thing is that we put count by months, count baby months method for a baby, and we would throw an exception if it's too old or future date is given for a birthday. So that is also another bad thing. And a design like this is flawed, and a design like this cannot be used anymore. So inheritance, like I just wrote, with human stages is invalid, and you would need to do hacks in order to make it work. Hacks such as splitting stuff, overriding stuff, using empty constructors, and so on and so forth. It's not truly what you want. So inheriting in this case is not so good. You would need to split baby probably in a few models, in a few parts, where birthday, where it actually has an age, but that age gets converted into months, and when you print information into string, you print that it's months and not years, you convert it, and so on and so forth. So it would need to be redesigned for a proper inheritance. We will do the redesign a bit later. So let's make a more simple logical case. We have human, female, and male. Human has an age and a name. To create a human, we need to put to write a constructor. So a human has to have an age and a name. Probably a birthday as well. So date, time, birthday. Set, get. So we I'll actually borrow birthday class from this one. Um, Oops. So let's go back to human, and it won't be daytime, but it will be birthday. Birthday. So to create a human, we pass in his name or her. So string name and daytime, birthday. So we set the name to name, and we create birthday is birthday. I mean new birthday, we pass in birthday, more like birth date, time, date, time. I guess it makes more sense, a bit more sense. So I'll camel case it a bit. Okay, and we should calculate the age. So the age is we'll do the same logic that we cannot create people from the future. So private void count age, private int count age. You pass in date time, time, birth date time, and you return back result. But first you check var dates difference. It's a time span when you take away two dates, when you take a difference from two dates. So first things first, we check if date time now is less than the one we want to set, and if that's the case, we throw an exception. Cannot create people from future. Now if it's not, then we take a difference. And the difference is years, is the age of a person. So we return years, total years. Total days divided from 365. And we cannot do it because it's double. So we math dot round, not round, but floor largest, so ceil. We do ceiling, which is converting the divided date time to a lower integer, towards the lower integer, and we convert the result to integer because everything that math has is a double, so we have to cast it. Since we converted it to an integer with ceiling, I mean, since ceiling returns a double, which is actually an integer, we can safely cast it to an int. Because that's what we need. So it drops a fraction, which doesn't exist in any way. So age is now actually when I think about it, we should always calculate age, and it shouldn't be a static thing. So it should be changing. So I think it makes sense to put this in a getter and have no setter for it, just a getter, because age is not a fixed thing, it changes. So it really makes sense to return it calculated. and we put private date time, birth date time underscore, because it's private. It's a field, and fields are underscore names. So instead in constructor we set that one, underscore. And we put in this one, we can convert this to arrow function, but I won't do it for this lesson. It's too much for the scope. So this is how we get an age. This is the proper way of doing it, I think. And now we can model inheritance. So our female inherits human. So both female and male are humans. And let's try and test it. Oh, nice, lesson 1. Great. I will move the lesson 1 things to a different file. So lesson 1 will have no static things, but cool things only. Public class lesson 1, private void lesson 1. Run. And let's put everything in a class. We don't want statics, and we can run the lesson. So we have our lesson 1, which we won't use for now. Save. And now we will do the same for lesson 2. So let's create a class for lesson 2. And in this lesson, what we want to do is to run it and that's all, to run it. So inside of it, we would like to create a human. A female, and a male. And if we hit Ctrl F5 now, we have errors, and those errors are because we can read what it says. If we go to the female class, it says that it doesn't that our human does not contain a parameterless constructor. So what does that mean? What it means is basically it says that in order for us to create a female, we have to define such a way. And by default, like I said in the first lesson, if you don't provide a constructor for a class, it takes a default parameterless constructor, a constructor without parameters. So female has a constructor without parameters, but a human does not. So we have two options here. We either have to write a constructor with the same definition as a human, or write an empty constructor for a human. And since we still want to create a female using a name and date time, its birthday date, so we are better off defining a constructor for female with parameters. And we need to do that because creating a female is consisting of two parts. First, creating a human, and then transferring that information to female. So they must share a constructor. They must be built in a similar way. So, just like a constructor for a human, you start with the class name, and we said that we would like to have a name and a date time, which is birthday, which is birth, date, time. And in order for us to use human constructor, humans base constructor, we do it with a base keyword. So by writing base, we say that we use humans constructor in this case. And humans constructor, so we call humans constructor now with the same parameters that we. Yep.
We hear you with spikes. The voice has some spikes.
Is it for everyone?
What?
Guys?
Yeah, the lag.
Yeah, spikes.
Yeah, and I keep getting disconnected sometimes. I'm not sure if it's just me, but yeah.
It probably is my connection. Ha. Okay. I'll try to sort it out for the next time. I'll try to use a different internet. Maybe it'll help. Sorry about that. Okay, so we have a female class which uses a base constructor of a human. So we pass in the same parameters to the human base, and now we can create a female using a human. In this case, it's absolutely the same. Human and female have no distinct features. So we'll leave it at that, and the same will go for our male class as well, for now. So all we have to do is to change the name to male. Now, if we go back, we created a human, so we need to pass in the parameters. So let's just go ahead and say new date time, and we pass in 994. Let's write the year 994. 9 September 4th is the first date. Jaina 2004. Hans Rick 2000s 4 3 17 14. Okay, now if we hit run, we still have an error saying that lesson 1 does not exist. So we won't be using lesson 1 for this one. So all we want is lesson 2. So we have a lesson 2 class, so our lesson 2 we created lesson 2. It's not like that. Lesson 2 is with 2 and not 2 a number and not a word. So lesson 2 run. If we hit Ctrl F5 now, we see that it compiled and that it ran. Let's make a small change. Let's go to baby class and steal the toString method to print information about the baby, about a human. So age is years. So we calculate our age. We count age, and birthday is birthday we take birthday time. Nope, I'm saying bullshit. We take birthday and we take month. We cannot use it because not sure why. Birthday, 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 birthday. What's the spelling? Oh, I see. Non-capital letter. Okay. So we used our birthday here to print information about the birthday and name and age in years. So if we go back to lesson 2 class, we put all of them into an array. But the thing is that this array, we don't need to make a separate array for humans, for females, for males. The thing is that female and male, they have the same class, the same base class. And what that means, they share the same form. So this thing is called polymorphism. It means that a female is both a female and a human. It has multiple forms. A male is both a male and a human. It has multiple forms. And what that means that we can have an array of humans. So humans, and we can put all of them into the same array. So human, female, and male are all the same in the essence. So we iterate through each human. In humans to print out their information. Let's just add 1 to it. Makes more sense because we want to iterate human, and human 1 in this wouldn't make sense. So if we hit Ctrl F5, we see this kind of view. Since you cannot see it, I'll paste it in Discord. So lesson material, lesson history, I'll post a screenshot what you can see now. So this is the view that we have when we run, when we hit Ctrl F5. We print information about each individual. And they work the same because they are from the same base class. Now let's go deeper, and we have our professions. And our professions are independent of a gender, mostly. So cleaner can be both female and male. Firefighter, the same. I don't know what general does there. Oh, general, right. So cleaner can be both female and male. Firefighter, the same. Police officer, the same. Recruit, the same. Soldier, the same. Student, the same. Teacher, the same. Worker, the same. But nun can only be a female. Priest, priest can be both, I think. And that's all. So the only example in here we have nun. So it's only a female. If we hit, we can use implementation automatically. So let's inherit from appropriate classes. Cleaner can be both genders, so it inherits a human. Firefighter is both, so it inherits human. And same for others. So let me just quickly do that. Sure, human. Actually, for general, I'll leave it for now. Monk is male only. I forgot that too to mention. Nun is female only. Police officer is both, so it's human. Priest is both, so it's human. Recruit is both, human. Soldier is both, so it's human. Student is both, so it's human. Teacher is both, so it's human.
My Visual Studio crashed.
Really?
Yeah.
Damn it. I think this thing is not so stable yet. Oh crap, human. Okay, so we just made inheritance for appropriate genders and professions. We associated a gender with a profession or with a base class in general, because we want to be able to congratulate a cleaner, to say happy birthday to it, and we want to do the same for a firefighter, for a general, for a monk, for a nun, for a police officer, and all other professions. And for us, in order to do that and not to repeat ourselves, we use inheritance. Let's make it a bit more interesting. So, we saw that we have a private method count age. What if we wanted to call that method from cleaner? So, let's do it. Count age. No autocompletion, no suggestions, and it does not exist in current context. That's the error message that we get. So, like I said, for a method or a property or a field to be used, inherited by another class, it needs to be either protected or public, and count age is neither of that. It's private, and that's why it did not get inherited. And it makes sense. We won't be counting age anymore. We have it defined for our human class. So human defines how age is being counted. And that's all. And we won't need to do it in the inheriting classes. It's done. So, what if we wanted to say that some things can be done in the inherited classes, but internally, from the outside, you don't want that something, that method or property to be seen? So, let's say you have protected method, not method but field, which says your bank account information. You don't want to expose it to public. You want to keep it secure. Bank account. Bank account. Note that protected are still properties because they will be used in potentially more than one place. since private will only be used in the context of the class that you define it in, you don't have to write setter and getter for it, but protected potentially will also be used in multiple places. So let's create bank account. Just small things. Um, public public string ID, set get, and private string password hash, and
Okay, right? Oh,
yeah,
no. Prop. For it's a shortcut.
not sure what you meant.
Sorry. It's this.
Oh, prop, yeah, and tab.
This doesn't work.
I don't know why it doesn't work for you, maybe, but for me, I know what you mean. There's a shortcut for writing properties, so if you write prop and press tab, and Visual Studio generates a property for you, but I never got used to that. So, bank account. So public bool. I'll just put both of those as private. No need setter and getter. Underscore ID. So public bool is valid. You put in string ID, string password. Your password gets hashed. Private, not necessarily hashed, but and not decoded, but encrypted. Encryption. Hash. Get encrypted hash. Let's say some security algorithm. You pass in your password, string password, and let's say we return something random. Let's say our security algorithm simply, actually we can get a hash of a string, if I remember, hash get hash code, and that's an int. So let's say it's an int. So if we get hash, so we'll change password hash to int as well. So if we get encrypted hash from a password and it's equal to our password hash, that means passwords are matching. So if ID matches ID, if it doesn't match, we stop immediately. So we return false. And if it doesn't match, we return false. If the hashes don't match, we return false. And in other cases, we return true. Okay. Obviously, that's not the way to do it, but just an illustration. I'll call it an account. And a public class bank account. So bank account inherits account. So it has all the things that the account has. Yes?
We can't hear you at all. I mean, the spikes are so many.
Damn it. I don't have a wire to fix my internet properly for today.
Now it's better.
Yeah, I can see myself that I'm spiking based on the connection. Maybe someone else in the house is using internet, so that's fine. Okay, so we have bank account and account, and all we have to do now is to use the same constructor. Make public and is valid. So we have to use both of those parameters. I mean, we would like to set them always and not allow having an account without an ID or password hash. So public account string ID string password, and ID is ID, and password hash is get encrypted password hash. Password hash. Okay. Password, not password hash. Okay. So we can do the same with bank account. Let's say it's absolutely the same. If it's absolutely the same, all we have to do is to write a constructor which uses the base constructor, and if we don't want extras, we leave this empty. So that's very simple thing. So why I wrote this? Protected bank account. A human has protected bank account. We don't want to expose this to public. If you go to a cleaner class and for a cleaner, it doesn't really, well, sure, it does make sense. If you go to a cleaner class, you can say public float get salary. I will change this right away, but bear with me. So public float get salary. Public void add salary to bank, and I'll go quickly back to bank account. Our bank account has balance, so public float balance set get. So we start from 0, from the bottom. And we, sure, balance. So if we go back to our cleaner class, we get our salary. Let's say it's hard-coded fixed salary, which is 300, really low. And add salary to bank will be get salary var salary is here, and bank account, we can access it. Balance, we add stuff to our balance. Since bank account was protected, we can still access it from the classes which inherited. So cleaner inherited human, and human had protected bank account, which is still usable after inheritance because it was protected. If we change bank account to private, like this, and go back to the cleaner class, we can see that, well, first it doesn't recognize that it's an instance of a bank account. Now it considers this as a static class, but it's just because that bank account is now out of scope because we made it private. Let's go back and return it to protected, because we want human to be able to have a bank account so that they can have some money to store. Now we have two methods, get salary and add salary to bank. Also, I didn't notice, but we had a worker method. Not method, but class. So worker, everyone should be a worker, not a human. So our professions, I'm changing fast, are all workers. Everyone is a worker. And it also doesn't make sense to differentiate classes based on gender, unless you need specifically the differences that the gender provides. So a better design is to have a human class and then a worker class. Well, female and male for human, and then worker for human, because worker inherits human, and then each profession inherits worker. Maybe a better name than worker, because worker is a bit ambiguous. We can rename this to profession instead of worker. So we have a profession instead, and each profession, like cleaner, firefighter, inherits profession. And all professions should have two things: know how you know what salary it has. So we go to profession, we have salary, and it's definitely not a method but a public property. Public float salary, set get. And another thing that you probably would like to have is a budget balance. Maybe not, actually, never mind, you don't want that. Bank accounts for that. So add salary to bank. Yes, that's good. We don't need this, and I'll change it a bit and call it get salary, and not get salary, but get paid for monthly work. Right. So we add salary, your monthly salary, to your bank account balance. We don't need get salary anymore. So we have salary and get paid for monthly work methods. And now our cleaner has the same. If we call get paid, we see that it exists. When we create a profession, we would probably like to add one extra parameter to a constructor, which is salary. So let's do that. So we say that our salary now is equal to the salary from a constructor, and all the places where we used our salary, we need to expand it. Can I do this automatically? Nope. not quite the way I want. Profession has it now. All is good. And now if I go to cleaner, I need to add those few things, such as salary, float salary, and pass it to the base. And I'll just copy this, and each class now should have the same thing. I'll probably mess this up if I do it, so I'll copy paste in 9 more places. So the same for monk, the same constructor for nun, the same constructor for priest, the same constructor for soldier, the same constructor for teacher, and that's it. Recruit. Recruit, police officer, salary exists, and student. Now, a few things to note. A student does not have a salary. The student is studying. So, we can set salary to 0 by default for a student. None.
For the currency, you prefer float.
Oh.
Can you use double or decimal?
For
I prefer decimal.
Oh, decimal. I always use floats, and I'm not sure if it's the right way of doing it. With numbers, I mean, with where it really matters, you should probably use double precision. Decimal, what's the decimal accuracy? Decimal. I think decimal is, well, I don't want to mix people up, so I won't say it. I'm not sure. I think it's less accurate than float, but it's faster than float. In any case, double is for scientific calculations.
Microsoft Doc says that decimal has more precision and a smaller range, which makes it appropriate for financial and monetary calculation.
Decimal.
Yeah.
Let's see. Decimal.
Never mind, just something to consider about money.
Yeah. Float. I'll just change it then. Decimal. Okay, I changed. Now, everything that's money based is decimal. So, let's continue. We have a bunch of professions. We have our soldier. So now each profession has a salary. And the thing about professions is that each of them should be able to do some kind of work. So a profession by itself does not exist. And I actually don't want to do it what I would like to, the proper way of doing it. So just for the sake of simplicity of this lesson, I will make a virtual method which every class needs to implement. So public virtual every profession class needs to implement. Public virtual void do not do work, but just work. And I will throw an exception if it's not implemented. So each, note that this method is virtual. What virtual means is that you can override it. You can override its behavior in the inheriting classes. So public override void work. So a cleaner cleans. Cleaning stuff. Then firefighter fighting with fire. Monk says praying. So does a nun. And so do other classes. Lastly, a recruit knows how to fight. And his work method does actually that. It lets him fight. And fighting logic. And lastly, a recruit has a commanding officer, probably. We also saw a recruit is a soldier. So a recruit is a soldier. And a soldier has an authority, a commanding officer. I'll move those to a soldier. So now, when a recruit inherits soldier, it has the implementation of the overridden method from soldier. So if we go back to soldier, soldier needs to have another soldier as an authority. Authority. A soldier should also define how you get a promotion or demotion. So public void demote. And then it goes down in the rank, and public void promote. It goes up in rank. So a soldier can fight, it has authority, it gets demoted and promoted. And recruit, the same, so I won't add anything extra. And general, I will make another class, call it commander, or more like leader. Military commander, I'll call it. What it has a bunch of soldiers to command. So public list soldier units to command. And general, and this gets from soldier, and general is a military commander. And let's make one more. Lieutenant is a military command as well. Lieutenant is a military commander as well. So, the thing about general is that when you create a general, you don't have authority ever. More like when you cannot promote a soldier above general. Public, alright, void, promote. And why is this not exposed? Soldier, promote, because it wasn't virtual. So we go back to promote and demote. So logic of demote for a recruit, if we go to recruit, public void demote, override console, right line. We cannot go lower than recruit. Also, I think the logic of how demotion and promotion works, it should return a new entity to construct a soldier of a new rank, a demoted or promoted soldier, and they should be in a way of a linked list, but that will be a bit later discussed. So let's go back to the soldier. So it returns a soldier. It returns a soldier. So for now, not implement exception. New. And the same in here. And if we go to recruit, we return itself. And for promotion, we create soldier promote. After recruit goes what? Lieutenant, I think. So we return a new lieutenant from this recruit. Name, capitalized name, date time, birth date, birth date, crap. Oh wait, we have it. It was private. If we go to human, we see that we have birth date as private, but now we need it as public. So we need to make a few changes. We need to refactor this a bit. So capital, birth date, time. We have a setter and a getter. We cannot do that sadly. Okay, next. And setter, getter. Now it's a property, now it's protected, and it persists. So if we go back, we can create a new lieutenant, but we will always have to write for each rank how we create from one rank another rank. We will always have to write two parameters, which is name and daytime, but we don't want that. And now that I think about it, we don't even need to expose the daytime, birth date time as a parameter, as a protected property. So I'll just undo it, because we can do a little thing. I'll undo a bit more because we can do a little thing and write a constructor which converts one entity to another, and that constructor goes to a soldier. So our soldier now will have one extra thing. You pass in another soldier to the soldier to create a soldier. So you can transfer ranks like that much more easily. Unfortunately, my idea will probably not work so well, because we don't have still the date of that soldier.
Oh, I'm lagging. Sorry.
It's okay. I mean, it's not okay. I hope you recover from that. Lastly, salary, soldier, salary. Okay, so we transfer ranks like this. We still don't have birthday, and we would like to get birth date time, and I guess I will simply make a method which returns it. So we'll still need to make it protected. Or we can just do a getter method to get our datetime. Public datetime get birth date time, which returns our birth date time. So if we go back to the soldier, we can call soldier get birth date time. And like this, we have created a way of transferring ranks, of promoting and demoting. So if we go to lieutenant, to recruit and promotion, promotion is done by passing itself this. Alright, it needs to have a way how to build itself. So I need to go back to soldier and have a constructor which uses that as well. So I go to lieutenant, I say public lieutenant, and paste the constructor. So now our soldier can be constructed and ranks can be transferred. Public, general, paste. And last but not least, military commander in general. Public military commander. Okay, so let's go back to lieutenant. And let's go back to recruit, and now we pass itself to create a new rank, lieutenant. If we go to lieutenant, we override promote, override soldier promote, and we return a new general. from itself. And demotion missed in the I. We return a new recruit from itself. And last but not least, recruit should have the same constructor like the rest. Public recruit. Right. So recruit returns itself. So when we create something from a base soldier, we should be able to say that that change happened, the promotion happened. So we can change logic a bit. When we build a soldier from soldier, let's say a lieutenant from another soldier, like a recruit, we would like to print in a console that such a thing happened. And the best way to do it would be soldier get type not full name, just name, not base type, just type. Yes, that's what I want. So what we want to print to console to test this out, rank changed to this one. It's a bit of a reflection, I won't go into details now about it. So let's go back. I'll change balance to decimal and promote for general will throw an exception, will return itself, return this, and soldier. Okay, so let's try it out. We go to our lesson 2, run. We created males and females. So we had our human experiment. I'll call it like that. Public void human experiment. And now let's write one more. Public void soldier experiment, where we will create a bunch of soldiers. Var soldier 1 is new recruit with a name Michael and birth date time new date time, which is 194 317, and salary 450. And let's make a bunch of soldiers. Call it 2, call it 3, call it 4, call it 5. And
Hi.
Hello. Lieutenant, General. Good enough.
Hi.
Hello again. Can you hear me?
Yes.
Okay, soldiers. So let's try to promote each soldier once and see what happens.
So,
Oops. Okay, soldier 1, soldier 2, soldier 3.
Where can I find the ID?
In lesson history. Soldier 3, soldier 4, and soldier 5. For each var soldier in soldiers, I will change this to soldiers and I'll change this to array of soldier. We promote each soldier. And let's see what happens. Control F5, we run. Nothing happened because we didn't run our lesson. So in our lesson experiment, we run soldier experiment. We hit Control F5, still nothing happened. If we go to our program, we run our lesson 2. They're all recruits, no soldiers, no exceptions. And we create one soldier from another. Not sure why it's not doing what it's supposed to, so I'll just hit a debug. And let's see what it gets, what it calls. Okay.
Visual Studio crashed again.
What?
My Visual Studio crashed again.
Really?
Yeah.
I was debugging, and I was using ReSharper at the same time.
Oh, you have Sharper.
Yes.
Uh,
I think it messes it up completely.
yeah. Have you buy it? I mean, it's too expensive.
Okay, create new general. I create new general. I get salary. I go to base profession. I go to human. And I go to soldier. No, I didn't go to soldier. Wait, I'm still in the soldier. Huh. Okay, I'm a bit lost myself now. So we have a recruit. For general, it's simple as that. So we have a recruit, and a recruit gets promoted.
Okay.
Alright.
I can join.
Okay. Soldier Michael, I'll stop debugging and I will do something for the sake of my own good. We have a class, and a class holds rank, but it would be nice to enumerate the ranks that we have, even though it's a bit more than that. But it's still useful, I think. So let's do that fast. Spiking?
It's taking forever. It's like configuring collaboration services.
Oh shit. I think it's my internet today that's messing it up. Okay, rank. Military rank. I'll call it an enum called military rank. Public enum military rank with ranks. I'll just say the names: recruit, lieutenant, and general. So when we create, so military rank is public for soldier. Public military rank. Wrong class. Soldier. Oh, it was the right class. Never mind. Public military rank. Set get. Rank set get. By default, it's actually I won't set it here. By default, the rank is a recruit. For recruit, I don't change it. For a lieutenant, I change it. When I create, I say that in both cases that rank is lieutenant. So here and there. And for general, I say that rank is general. Okay, done. Now it will be much easier for me to debug because I'll know what rank it is and what should happen and why it doesn't happen. Let's go to recruit. No, let's go to
Pass the rank in soldier class. Soldier class.
what about soldier class?
Could we pass the rank?
Rank.
Yeah. So general and I don't know. I just
No, we cannot because soldier. Well, if we, it's a bit out of scope, so I'll leave it there. But if you did it the proper way, soldier would be an abstract class. Like soldier by itself cannot exist. It needs to be either a recruit, a lieutenant, or a general.
Okay.
And then you can create it. And what you said, yes, you can pass a rank to some method or constructor, but that is not for a soldier to decide. It would be like a military registry, like a military base where you just create soldiers by passing their ranks. That's where it should go. It's a bit different responsibility.
It's working now. Now I can see what you're doing.
Okay. Right. So, I was wondering. I hit Ctrl F5 and I got a bit lost in the way semicolon in the way the inheritance worked. We have a soldier whose rank is recruit and it gets a promotion. So it should call a promote method. Whoop. Lieutenant again. Rank lieutenant. Promotion means you create a general from lieutenant. So you return a new general. Then you call the base constructor for a profession. Oh, okay, I see where I fucked up. I fucked up here. So, what I presumed, I pass in. So, what, do you guys understand what went wrong? Like, I was wondering why this was not called. I was wondering why this was not called. So, do you understand why this was not called?
Pass in general constructor soldier.
Yeah, I was supposed to pass soldier in the base as well, and not the separate ones. And only soldier should have this one. The other should not, because then I don't call this constructor, but I call this constructor, and that's why it got messed up. It's actually a good example. So let's go back to our lieutenant. Lieutenant gets past the soldier as well. And same for general. And same for recruit. So if we go ahead and hit Ctrl F5 now, nothing happens. It should have happened now, right? Let's hit and see what happens. So we have a recruit which should be promoted to lieutenant. So we create a new lieutenant. We pass base soldier to lieutenant. Right. Lieutenant is a military commander as well. So military commander's constructor should also have that. Because military commander has units to command. That's why we separated it a bit. Let's hit Ctrl F5 and now let's witness how the promotions work. So this is what we see. So when we hit, we see that ranks get changed incorrectly because I was supposed to get a rank of the one that I create. Let me fix that somehow. It basically says what rank you are right now. That's the problem, and not what rank you got changed to.
Yeah, you gotta change, like you gotta print out the enumerator, like the enum instead of the class.
Actually, wait. Alright, I put a new one. Okay, I have an idea. I know what to do. No need enum. Actually, since I have enum, I can print enum, of course. If I go to soldier, we have this. So yeah, I can print the rank much better. Actually, I wonder. So the type persisted. Actually, yeah, the type persisted somehow. So it becomes Oh, it's the one that got passed. That's why it got like this. If I say this, so, yeah. Okay, from soldier. Of course, rank would be the easy way to go. Hands down. But I'm also curious about reflection. Let's hit Ctrl F5. Okay, from recruit to lieutenant, from lieutenant to general, from recruit to lieutenant. Okay, nice. Alright. So I'll change get type to soldier to rank. Nice. No need this. Okay. So like this we converted different types and used polymorphism to relate to them, and we used polymorphism in a way that we could work with every soldier as if they were the same entity, but they were recruit, lieutenant, general. They were different entities. So they did a similar thing, but each did it differently. When we promoted our soldiers, lieutenant became recruit became a lieutenant became a general, recruit became lieutenant, and this one became also lieutenant. So that's an example of polymorphism, and those were the examples of inheritance. So let's wrap this up. So last lesson we learned the first principle of object-oriented programming, which is classes, properties, and what those give us, which is encapsulation. Another principle of object-oriented programming is inheritance. It lets us reuse our code really easily by transferring properties and public or protected methods from one class to another via inheritance relation. One thing to mention is that you cannot inherit two classes at the same time in C#. There are languages which lets you do that, but C# does not. But we will sort this out in the next lesson, a way around this. So last but not least, inheritance gives us multiple forms for different classes, and they can be used as one via the common form that those different classes have. The base class can be used, and then when you call something from that base class, it will be it will still call the true form methods of that class. For example, if I call promote as if it was soldiers, it actually calls promote of the class I instantiated from. So recruit will have its own promote, lieutenant will have its own, and general will have its own, because it doesn't even matter to all soldiers. They will each have its own implementation of that method, because I overrid the behavior. There are different methods how to do it, about those in the future. So, three principles.
Like methods hiding behind other methods, or
Sorry?
so it's like a true implementation of a method hides behind like an abstracted method or an abstracted class, like a class. An implementation of a class hides behind another abstract class.
Yes. So you work with abstractions rather than with concrete details. You know that the soldier knows how to do a promotion, and that's all you care about. You don't care about the details. Details go to the child classes. Abstract is a bad word in this case. We use virtual methods in this case. In the next lesson we'll talk about abstract things. So, three principles of OOP. Encapsulation, inheritance, and polymorphism. Encapsulation is having bundled properties and methods into one. Inheritance, sharing the same properties and methods as long as they're protected or public via inheritance. And polymorphism, working with abstractions rather than working with details via multiple things such as inheritance or polymorphism or interface. That's it for today. Do you have any questions? Alright, that's